we have many interesting talks. This is going to be like a different format, or we want to make it a different format than the traditional workshops. So I will explain a little bit more about that later. First, it was interesting to see that apparently in Pasadena, we can already feel at home with this graffiti of paint. So it was none of the organizers, it was not Robert or Marcel that were doing that. So this was an interesting fact. Okay, so we also want to thank all the program committees. So we all know how hard it is to try to allocate time to review papers. And well, we really want to thank them because again, we are not capable of making this type of events without people participating. So thank you so much for all the effort, the good reviews. And then for this time, we have 4 accepted papers. So first we have Advanced Game Engine Wizardry for Visual Programming Environments. Then we have block-based platforms for defining adaptation rules. Then we have supporting construction of domain-specific representations in textual source code. And finally, we will close with bridging incremental programming and complex software development environments. So this is the program that we have. As I mentioned at the beginning, the idea of this workshop is more to have this writer's workshop. So the idea is that we give feedback to the authors. So it's not only about the questions we might have, but more about reading the papers in advance or having a summary of that paper. And then the idea is to help the authors to tell them how to improve the work. So more to try to build like a community where we help each other rather than, okay, the paper is done, bye, I continue with the next paper, but more how we can improve and how we can help each other with all these topics. So we have a lot of experts here. So this is the main goal of the workshop. So ideally, we want to split it in 3 parts. First, to give a brief summary of what we understood about the paper, what we thought the paper was about. Then to give some positive feedback, so to encourage like, okay, this was very interesting, this was something that I find very clever and that should be like improved, that can be highlighted. And then in the last part to give suggestions. So of course the work is there, we have clear ideas on what the authors wanted to express, but maybe based on our expertise, we can tell them like, hey, maybe have you look at this, or maybe this part was a bit weak, you can try to improve this part a little bit more, or a deeper analysis on some different aspects of the system. So this is a brief summary of what we want to have like from you to follow this structure. So to give you also a more like of a structure, so you can split this feedback in 2 ways. So one, focus on the form of the paper, and you can take inspiration of these questions like, what did you gather, understand from the piece? So what was your understanding of this piece in terms of form? What aspects of the piece worked well to present the ideas? So what's interesting about the work, and what was like something that you really want to highlight? And then what aspects needs improvement? So again, in terms of form. So again, these comments must be in the form of suggestions. So we are not here to criticize anyone, but just like to give, nice feedback. And then when we talk about the ideas, so what were the ideas of the paper maybe? Which ideas seem like good ones? So why you consider some of the ideas that these papers present interesting? And finally, which ideas need improvement, or maybe you consider, well, maybe you can just remove this and focus on a different aspect to highlight that. And at the end, we would like to have the authors give some clarifications. So again, the idea is more that the author is not really presenting the work, but we are discussing and giving feedback to the author. And then at the end, the author can give some clarifications. Maybe there were some misunderstandings in the way that the work was presented or that was written. So now we are very happy to have Yoshiki here as an invited speaker. So please welcome Yoshiki.
think. Okay. Okay. I don't know. It was working
Yeah, before it was super
before.
smooth. Maybe I just mess it up.
I think.
Yeah, okay, now it's there. Yeah.
What just? Did it lose the mirroring? Yes, it did. Ay, ay, ay. What? Do I do this?
Do you want to have it mirrored?
No, yeah, it's better be mirrored. Yeah, I know. Yeah, that's fine. Why it was working and not now? So is that fault? I cannot do the mirroring. How do I do it? Is that a key to press? What's the magic key to do the mirroring?
Oh, yeah.
Could you switch off the true tone setting?
Sorry?
Could you switch off the true tone setting?
What?
The true tone. So if you go to displays, yeah. Yeah, this one. No, the
Oh,
other one,
true
the one
tone.
below. Yeah.
Collaboration. That's my theme here. Okay, I think, I should do this, right? Oh, it's going to be hard. Hello, my name is Yoshiki Ohshima. And yeah, thank you for inviting me to the workshop. And I'm a computer guy, and my projects tend to be interactive, visual, collaborative, like end-user oriented, and live programmable. So my research interest basically overlaps significantly with the area that paint covers, no pun intended. And so I'm going to talk about sort of the projects I have done, and also much more about the ideas behind those projects. And yeah, I'd like to give you some different ways of looking at things, but also first and foremost, yeah, just like sit back and relax and enjoy my talk. And so before getting into the main part, I'd like to mention the tool I am using to do this presentation. And this is called Croquet Greenlight. And it is a 2D collaborative software, like it's an infinite canvas, like where you can embed like other web pages and other contents. And actually, Marcel here is in the same room, so he's moving his cursor. And I should do this, actually. Let me do this. So we are seeing the exact same thing on his computer and my computer. Oop. Oh, please don't. And so you might think that this is like Miro, and what's the big deal? But this is a little bit more interesting than Miro. So for example, I can resize, hey, and Marcel, can you move the window? And we can do this. And you cannot do this in Miro. In Miro, for example, you try to move something, and you release, and 1 second after, it changes on the other screen. So when I talk about real-time collaboration, this is the kind of things I'm talking about. And so so as a part of my this network is a problem here. Yeah, if you are watching like some anime here, don't do that. Okay, this is not great. Half working network is worse than like not working network, right? So okay, let's try to. So anyway, so this is a part of self-introduction, and I was a student at Tokyo Institute of Technology, and I was supposed to be studying like compilers and object models, but I was sort of stuck, and I started procrastinating. And I found an open source programming environment called Squeak, so I just started playing with it. And one of the things I did was to port the virtual machine of Squeak to Zal's PDA. It's a little small. And so back then, like this, around this time, Japanese used to make the best electronics gadget in the world. So the combination of sort of the very high-end PDA and this malleable and the multimedia-rich programming environment, that combination got some attention from the Squeak team who was at Disney. So I end up with doing internship at Disney and later hired as full-time. And the first project I did was PAX PDA, and I'm not going to talk about this here, but you can, if you are interested, you can read the paper and other talks. But by the way, this web page looks like amateurish page, but this is actually collaborative software. So Marcel, can you scroll the page? And it scrolls. And so if you want to join, scan the QR code, do it. It should be, hopefully, you need to be brave to do this kind of stuff. And anybody can scroll. So yeah, so that's so the instant collaboration is another thing I'm interested in. So the PAX PDA, as I said, there's a paper and the device looks like this, but I'm not gonna talk about that. But through this work, I got to know Alan Kay, and of course everybody here knows who Alan Kay is. So he's one of the biggest visionary and the pioneers of the computing field, and he is known as the father of personal computer because he, among many other things, he conceived the idea called the Dynabook. So in 1968, when computers tend to be a big thing, like occupy like entire floor of a building or stuff, but he foresaw that Moore's law would enable like enough computing power to fit behind a flat panel, and the people will carry that kind of device around. And and he made a mock-up like this. But many people often don't understand his bigger idea. So many people thought that Alan was talking about hardware, and that's it. So sometimes people said that when iPad came out, oh, iPad fulfilled Alan Kay's vision, Dynabook, but it wasn't. So Alan's idea was what kind of new services the computer would provide, and what kind of changes that will bring to the society. So if you look at this picture, this is drawings he did in 1968. And if you look at, so because of course those children are carrying around portable devices, but if you look at those screens, they are looking at the exact same thing, like Marcel and I are doing. And they are playing a multi-user space war game here. And not only they are playing that, actually they made the program by consulting online library and talking to teacher. So they made the game together and playing together. And so that's the future he wanted in 1968. And Alan Kay wasn't just talking. He decided to make it real. So the technology to make a portable device wasn't there, but he made an interim Dynabook and get children to program, and they are having fun. So he did that, and I said that I sort of got to know him. So this is me, this is my wife, and this is Alan Kay. So around that time, there were some other visionaries, and one of those was Douglas Engelbart. And of course, you know him. But one thing his group did was to present like the collaborative structured document editing and all those things, the mouse. And it's called the mother of all demos. But of course, it wasn't called the mother of all demos when he did it. So he was showing the mouse, like a structured collaborative document editing, and like a video chat, and talk to somebody and do stuff together. So again, people often think that, oh, Douglas Engelbart, he invented the mouse. But Douglas Engelbart's idea was also much, much bigger. So this was like the 60s, 1960s. And that's when the Cold War was upon them. And people worried about things like, maybe everybody will be dead, and maybe next week. So that's sort of in the air of the world. So Douglas Engelbart was like very concerned with the future of humanity. And he thought that the better organization of people helped by education and technology and make a better system that would augment human intelligence. And that's the way to solve bigger problems that one person couldn't solve. So he wanted to augment human intelligence to solve bigger problems. And so this is sort of the interesting picture. So here's a mouse, and this is Doug, and another mouse. So interesting thing to notice here is that this is a collaborative software, but they are using it even when all collaborators are in the same room. Today, if you want to collaborate with somebody remote, you have GetGo tool, maybe Zoom or Google Meet. But you are not going to use Zoom when your collaborator is in the same room, because Zoom does not augment your intelligence. It just lets you talk and maybe share screens. But this was their day-to-day, everyday working tool, and they used it. So by the way, this is Doug and this is my wife. And so their work was funded by government funded. There was a government funding agency called ARPA IPTO, and the JCR Licklider and Bob Taylor were two of the directors. And so in 1960, Licklider wrote this paper, Man-Computer Symbiosis, and he was talking about what's the future relationship between human and computer. So this was 1960, so he was one of the early thinkers of this domain. And later, Licklider and Taylor published a paper titled The Computer as a Communication Device, and this was 1968. And there were a few interesting pictures in it. So one picture was like this. So one person is presenting like the design, his design of bridge here, but others weren't just listening. They would be like checking the material strengths, or maybe some others actually wrote simulation and running it. So this image, this drawing obviously was influenced by Engelbart's work. But so this is sort of what they wanted. And another interesting picture in the paper was this. So this is an AI agent, and it's an inside joke, but it's named Oliver. And this is intelligent enough. So when insurance salesman came, this device figured out and say he's out. So that's sort of already in people's mindset in 1960s. So those are sort of the historical part I wanted to touch upon. It's coming back to the later part. But one more thing about something else before I get into like demos. And when I was invited to this cryptic acronym workshop, the two words, abstractions and notation, got me thinking about this. And I'm going to talk about like designing abstraction and notations. And when you are designing something, it's often good to think about the extreme cases, and then you get to a better feeling of the domain and where is the center and where is the boundary. So I want to talk about that a little bit here. So what came to mind was Maxwell's equations. And Maxwell had many different versions. Like this one happens to have, I think, 12 equations in it. But himself and his collaborators and actually the successors of him it took for them like 30 years to get to this 4-equation version that we know as Maxwell equations today. So it was a long process, and even Maxwell himself didn't finish it. But so this is cool. Like the divergence of electric field is created by a charge, and basically time varying the magnetic field creates the curl of electric field, and et cetera, et cetera. You don't have to know this, but probably you know. But why do we stop at 4-equation version? And there's a thing called bivector in geometric algebra. And basically, bivector is a compound quantity, so internally there are structures in it. But then you can define operators on it, and that's the right thing. And with that setting, you can reduce those 4 equations into one. And it looks like this. Basically, the F here has like an E part and B part. And the nabla here is gradient operator. It's a 4-dimensional gradient operator. So you can do this. But then we need to go to the extreme case. So why do we stop at equation that describes only the electromagnetic field? And actually, I know the formula that describes everything in the physical world, and that looks like this: U equals 0. So but the problem is that I have no idea what's in U. And of course, nobody does. But another bigger problem is that even if somebody comes up with a plausible U, that is not going to help us to write programs. The stuff we would like to write about is not going to be described by this. So abstractions have an interesting notion. And by the way, how many of you have heard of geometric algebra? That's cool. And actually, so I was watching yesterday's video live, and Hamish Todd was talking about that. So maybe you have heard of it yesterday. I did not know about this until 1 year ago. But my high school kid actually came to me one day and said, "Hey, Daddy, do you know geometric algebra?" And I say no, and my kid said, "Oh, let's watch this YouTube video together." So that's how I got to know this. But anyway, so I'm not going to turn this talk into a mathematics lecture. So I'm not going to explain all things, but those are sort of more down-to-earth things we might write in our programs. And some abstractions work very well. So quaternions, only thing you have to know is there's an operator, and you don't have to go up and down the different abstractions. But vectors, often you do want to look inside and what's there and go up and down the different levels of abstraction. And the notation, if you are designing a notation, your notation should help that like fluid motion of moving up and down. So you do not want to write this horrendous kind of stuff, but rather if it's a plus, you use plus. If it's a multiplication, you do this kind of operators, and your syntax or notation should allow like going up and down. So that's what I thought when I was invited to this workshop. So let's look at some of the stuff like I participated in. And the first thing is eToys, and the network here, hopefully it works. Oh, okay, it's faster now. Oh, by the way, I should mention, there's one powerful idea in computing, and that is simulation. Your computer can simulate other computers. This is a powerful idea, and this is one example. So the Squeak eToys used to be a native app, but Vanessa Freudenberg wrote a virtual machine in JavaScript, so we can run it in browser. And this is basically graphical blocks-based authoring system. And this car is following this script, so forward by 5 and turn by a little bit. And I can change the script, make the forward by step differently. But also you can look inside of the car. So basically this is the graphical representation of the car, and this is the symbolic representation of the car. So X, Y, and heading are changing. And one thing we used to do is to draw another object, maybe like a steering wheel of Mazda's car, and say keep. So this is the same kind of object, and I can look inside. Oop. What's going on? Seriously, do it. It often happens when some other device is connected. Okay, so I can look inside the object, and this one also has X, Y, and heading, and I can rotate this, right? So that would be the sort of, that would get you thinking that, oh, maybe I drag the heading of the steering wheel into turn by here, and then, oh, this is pathetic. Come on, do it. I can drive the car by rotating the steering wheel. So this kind of stuff is what we used to do. Again, but the main thing is the symbolic representation and graphical representation on one screen, and they are connected. And one more thing, so one of the things I did was to make a particle system. So instead of just one car, there are 2,000 red particles in this, and this script is saying that each particle moves a little bit, and then when it hits the green ceiling, it give a little bit of momentum, and then go back. And the green one is trying to do constant acceleration falling. So basically the 2,000 particles are pushing up, green one is trying to fall, and it's showing the PV equal nRT gas law here. And one thing you can do is to reduce the, yeah, this happens sometimes too. Keyboard gets messed up. So you can reduce the number of particles. Wonder, okay, I will show a better one later. This is not good. But for this audience, one thing I'd like to mention is that so the eToys, so I didn't, of course, start eToys, but around like 2008, I assumed the like core developer's role, and then that got me on some panel discussion at Kai, and the eToys was shipped on OLPC, so like we had like 1 million install base or something like that. And for this audience, one thing I'd like to mention in relation to Greenlight is this idea of 2D finite infinite scrollable pane. And I got the idea from this work, from the self-programming environment, and they called it Kansas. So Kansas is a large, as they say, Kansas is a flat space where many people live in. So that's why it's a scalable infinite field. And there are many people join in the same session and do stuff together. And then, so Lex Spoon started a basically knockoff version in Squeak, and he named it Nebraska. And that's a little bit smaller, but still flat. And I'm not going to talk about this, but I myself did a shared space called Kanto. Kanto is a sort of flat space in Japan. So Greenlight was inspired by Kansas. And here, come on. I want to show the next thing, which is called Shedama. And, funny. So the Shedama is also a particle simulation, but the starting point was how do we teach science better? And in science is about making the invisible visible. For example, like air here, we cannot see the gas molecules. But we do not want to tell students that, oh, you cannot see them, but you have to believe it just because I say so. That's the last thing we want to do. So what students should be doing is make like instruments to experiment it. And in my case, I made a vacuum cannon that shoots out ping pong ball, for example. You can watch this video later. But also, they can build a computer simulation model by themselves and then run it and tweak it to convince themselves that, oh, what's happening here matches with my mathematics. So that's what we wanted. And this system is for that. So let's see. So basically, it's based on turtle graphics. So, but there are a bunch of them. So in this program, basically, I say create 3,000 turtles, and each turtle has XY and RGBA, and the fill random say, fill the X value of everybody between 0 and 512, and fill everybody's Y value between 0 and 512. And set color here says based on the X and Y, they get the different R and G value and draw. So 3,000 particles is hard to see, but I can say 30,000 or 300,000 or 3 million. And so there are 3 million particles, and this is live programmable. So this is often hard to do during the talk, but I am defining a new method, say move, that moves everybody toward this direction, and then loop says draw, the loop says move and draw. So I save it, and I loop, and everybody moves. So that's simple, and I'm switching to the next example. So there are 3,000 particles, and everybody has random positions. But here, each turtle has dx and dy. And that dx and dy are filled with random, like unit vector. So everybody has random direction. And if I run this step, so everybody is moving different directions, right? But what can be done here is to add the dy at every time. So I'm changing the program into like a gravity simulation on the fly. So that's Shedama. So here's another example. So this looks like a picture, but it's actually a set of particles, and their positions and colors are based on the pixel values in the original image. And this one also has a random direction. So if I say step, it does this dissolving effect. But this got me thinking, what if I use, instead of dx and dy, what if I use r and g and run it? So this means that yellow dots are faster than black dots. But one thing you can do is to change this to minus and accept. So it's like sticking your hand in the computer and changing the program. And this is, think. So people laugh and it's fun. But this is, I think computing should be fun. And if you have this kind of stuff, and if you have this kind of stuff, and also you have a bigger idea you want to communicate, I think having some instant, something triggers instant reaction is a great way to convey your bigger ideas, actually. So let's see, actually, one more thing. Oh, I forgot how this is actually implemented at all. So the idea is that this is live programmed, but my programming language here is translated into the shader language. So program is running on the GPU here. So it's running at the GPU speed, but I'm modifying the GPU code on the fly. So this is a game of life. But one thing, for example, you can do is to change the program while it's running. Maybe add a different case. And this is called high life variation. And you can experiment like game of life without restarting your simulation. You can change the condition and program while it's running. And I like this kind of sort of the interactivity and live programmable aspect of things. And that was sort of the several years ago. But we started a startup called Croquet. And so this was about providing a library so that people can make their collaborative applications. And we call it Croquet OS. And you might say, oh, it's just a library. Why do you call it an OS? But once Weizmann said that an operating system is software that manages space and time. And the Croquet is based on the logical time-based execution, so it's managing time, and space is like your data. So we said, oh, yeah, it's on OS. So that's sort of the marketing, but I embrace that. And you can write your own applications by using the software. Like the green light is written on top of Croquet. So the network part was done by Vanessa Freudenberg and with help from Alan Lanza and under David Smith's lead. And I didn't do much of the network part, but I wrote many applications on top of it. And yeah, I'm not gonna talk about how it works. One thing, going back to the green light, that's one example of Croquet, is that this is a web-based app. So you can embed other web pages. And I just embedded Google Docs. This is a real Google Docs. But when you are trying to collaborate with somebody over Zoom, and let's say you are trying to write a little document together, what you might do is to send a link to a Google Doc, and maybe send other links for the supporting materials and like references. But 5 minutes in, you start fishing. Oh, where's my Google Docs tab? And where's my other document? You have to find it among your 100 browser tabs. But in Greenlight, I have the confidence that on Marcel's screen, he's also seeing the Google Docs on the right and this document on the left. And I can point here and say, hey, Marcel, what do you think of this picture? And he's typing. So this guarantees that we are seeing the same thing and we can work together. So that was sort of the little idea that Greenlight enables. And here, I want to show something else. So another network challenging test. But nowadays, web browsers can do quite a lot, including 3D stuff. So this is a shared 3D space, and it's supposed to load like in 3 seconds. Yours did, okay. It's loading, yeah, so I mean, and this is shared space, so I look back and, oh, Marcel is white rabbit, and he can move. Yeah, move a little bit, for example. Yeah, so it's a shared space, and yeah, let's explore. Oh, by the way, yeah, he can move, and by the way, so here's a crane, and I can tap, and this moves, and if you look at the swinging is really synchronized. It's like basically the exact same, yeah, at the exact same time, it's in the exact same state. So but let's explore. Oh, by the, yeah, it's fine. I will take you now. So I say gather, and I'm doing a guided tour. Oh, it looks like a factory for drones. And they are testing one here, and it's going in circle. And it's going in circle because that drone is executing this program. This is actually a collaborative text editor. Oh, yeah, Marcel, I'll take you again. That's fine. So basically this says that when, so there's a method called step, and what step method here does is to schedule offshoot itself. So schedule itself 20 milliseconds in the future. So 20 milliseconds in the future, the same method will be executed. But while scheduling it, it rotates by a little bit and forward by a little bit. So that's why this drone is going. Okay. Like I said, half-working network is worse than no network. I can switch. Oh man, okay. So, but what I can do is to get basically the no-code tool here, and I can say duplicate. So when duplicate, the initialization part makes it start moving. So like this. And maybe I can delete the original. So they are going in circle because everybody is following the same program. But what if I change the forward by value from positive 0.03 to negative 0.03? So I edit it a little bit, and I'm hitting Command S, and everybody moves. So exact same thing happens there. So code is data here. It's propagated to all participants. And as I was shown, I used to do particle systems with dots, but nowadays I do it with drones. But interesting, if you want to do this in Unity, for example, what you have to do is like if you find a little change to make, you do it on your computer, you build a new version of binary, you send it to your friend, and in the worst case, you might have some server components you might have to update. So make sure that your friend installs the new version, you install new version, and then restart the application and go back to the same place and test. And it's crazy. But in this environment, you can, again, stick your hand in the world and modify it, and the effect is immediate. So you are still with me, right? So let's explore a little bit more. And so so there's some suspicious door, and I opened it, and there's a physics simulation. Or some engineers must have too much free time. And if you look at the screen, this is a physics simulation, but we are not communicating the positions. It's only the time is sent around, and the bit identical simulation is running on his computer and my computer. And for example, Marcel can tap one of those stopped thing, and it reacts. But when I was showing that gray rudimentary text editor to my ex-colleague, he said that or like, programmers are opinionated bunch. They are not gonna use that gray dull text editor. They have their own favorite editors and they have to use them. And I said, okay, this isn't a research project. So what I did, hopefully this works, huh? Yeah, so what I did was to have a little, like a change, like watch server, and I can write the program on my local disk, and that will be injected into the space. So let's say, and they have the different colors, right? And that's because I have a method called random color. Random color. And this one creates a random number and then computes the HSP and convert it to RGB. But let's say Marcel is a designer I am working with, and he would say, hey, Yoshiki, I don't need those random colors. I just need green ones. And I would say, okay. Then instead of computing something, I say 00FF00. And save. And now we only get green ones. And I'm not gonna go, so unlike that rudimentary text editor, this is a real text editor. And I use Emacs on other times, but this is more familiar to you. But not only tweaking some parameters, I can make a big change. So what I do other times is to add a new shape, like a cylinder shape, just changing few lines and change. So you can do that kind of stuff with somebody in real time. So that's sort of that's why like live programming is even more important for in collaborative settings. You just do not want to restart your world when there are other people working in the same space. So, okay, so now I think I go into the conclusion part, but it has some stuff to talk about. Oh, one thing I forgot to mention when I was talking about the vectors and geometric algebra and notation. So one thing I've been doing is like using AI for certain stuff. But in my mind, designing like abstractions and notation should be done by humans. AI cannot do it. Like I said, like Maxwell's equations took like 30 years from the initial idea to the refinement. And you need some crazy people who think that, oh, this is good. I don't care what other people say, and keep going 30 years with colleagues. That's how you might get a great thing. But AI is just looking at today's popular thing, and you should do this. So human should be in the loop in designing that kind of stuff. Yeah, that's an important message I wanted to say. So the last part, there are 8 pictures here, and the top row here is showing basically pictures of actual hardware, like form factor. And the bottom row here are analogies, or what it compares to. And so let's start from here. And from Engelbart's point of view, the mainframe computers were like railroads. It's clunky, like you cannot go places where you want to go. You cannot go places when you want to go. You need to coordinate with, you need to wait for other people, and you need to go like limited places. But for Engelbart, what they made was like an automobile. With a little bit of training, you can go wherever you want, whenever you want with your friends. So that's what he said about his computer. And the mouse is like a little volume knob of your car radio when he invented the entire automobile. So that's what he said. And as I said, like Rick Ryder's and Taylor's paper was the communication device, right? Computer's communication device. And it's a great analogy. It's just not for computing, but this new machine is a thing that connects people. So that's a pretty good analogy in my mind. But what stands out to me is the Alan Kay's notion. Forget about like devices and cars and stuff. This is a new thing, and it's like a book. It's a new medium. And it's a book, but it's a dynamic book. So you can do stuff on it. But not only it's just a dynamic book, it's a meta medium, so that you can write stuff in the book, maybe in a program form, and you can change the way you communicate with other people. So it's a meta medium. So that idea of like writing stuff in the book and changing the book itself, in my mind, this vision hasn't been fully realized. Even though, this stuff, like a square form factor with flat panel display, that's still what we use. But this vision isn't here yet in my mind. Don't have fun, yet. But when I do this storyline, natural question people ask is then, what's here? What's the form factor? And more importantly, what's the good analogy here? And actually, the form factor here is already here in many ways, or some of them. Like, our eyeglasses will be your computer. Like those light fixtures will be computers. Like your table will be a computer. And you may have a little thing at the corner of your room, and you say something, set a temperature or something, and you just say and something happens. So the computers are becoming invisible. That's why I don't have a picture here. It's invisible. But then more important thing is, what it compares to, what the analogy you want to use to describe it. And of course, I'm not a visionary, so I don't have a answer. In the analogies, there is no single answer. But I have analogies I don't like. And as I said, some computers let you just say stuff and something happens. So for some people, it's like servants or slaves. Computers are like slaves. But I don't like that. But when I thought of this, like, why do I even care if slaves are computers? They are not people. But what I don't like, I understand, is that not only the world filled with those slaves, what I am afraid more is those masters of those slaves. Those masters will delegate thinking and designing to their slaves, yet they pretend that they know stuff or they can think. And I am afraid of the world filled with those masters. So I want to make sure that doesn't happen. It may happen. So that's the sort of the recent project I've been working on. It's a Mozilla-funded project. It has a local AI. So you have a box at your home and you do stuff. And my vision is like this, basically. It's a collaborative space, but there's an AI agent in the loop. And of course, we have big problems we have to solve, and one person cannot solve. So people have to work together, but people can use AI agents if they can, and they are not slaves here. They are sort of the participants, and they will help you to solve bigger problems. And that's what I want. And this image is I made up and looks stupid, but I can show this, hopefully. And probably you have seen this before. So this is Tony Stark and Bruce Banner working in the same room, assisted by an AI agent, Jarvis. Right? And if you remember, actually, they didn't solve a problem. Actually, they created a problem in this movie, but it doesn't matter. So if the visual, if this visual bothers you, yeah, imagine like nicer one like this. In my mind, those are basically equivalent, and that's what I want to try. And I don't have stuff to show on that yet, but hopefully sometime I can show some good stuff. And yeah, that's basically end of it. So let's work together and let's like think better analogies together and let's solve bigger problems together. Thank you.
Okay, thank you so much for this very nice keynote. Maybe we have time for a couple of questions. Are there any questions in the audience or online? No questions? Online, do we have someone online? No? Okay, so maybe I have a question because again, so we usually, or at least in the work we have seen, sometimes we have to deal with people arguing like, okay, no, visual programming languages are better or textual programming languages are better. Do you see something concretely that you think like, okay, maybe we can come up with this different abstraction? You showed us some blocks, some text, something more like in between?
Well, yeah, in between or the combination of them, that's probably what I'm thinking of. So first of all, like text is visual. For most people, you look at it and understand it. It's not too different from stuff like this. Like, this is a visual program, Snap, but you can do vector operation in it. So it's not, they are not either or.
Yeah.
As you said, the best of both worlds should be possible.
Mm-hmm.
And that's what people should think about in my mind.
Yeah.
And there are editors where you can edit from keyboard, but you can also use some pointing devices. And nowadays, you can also think about talking about your program and do stuff. Mm-hmm. And eye gaze, all other, many other things can be used, I think.
Okay, thank you so much. Do we have any other question?
Maybe one online.
Yes, okay.
I was seeing that someone was writing.
Okay.
So probably it will be alright.
Probably that will take a while.
Tom wrote something.
Okay.
In JavaScript. Yeah, okay, there is one.
Do you have access to it?
Yeah, you're using JavaScript for coding. Are we moving to natural language exclusively in your future vision, or does it still involve structured language?
session. Well, second can of paint, maybe, for the paint workshop. We have 3 interesting talks, still following the writer's workshop format, right? So you will hear about 15, 20 minutes of presentation, and then we make a quick round of summary, what you liked about the work and what you wish to see improved. Maybe you have some ideas on how to improve it, and maybe if there is something else you would like to say. And the speaker can intervene, can just listen, their choice. So the first talk in this session is block-based platform for defining adaptation rules for automotive systems. And Mauricio, here's your stage.
Okay, thank you, Marcel. Okay, so good morning, everyone, again. So yes, Marcel mentioned, so now I'm gonna present some work that was mostly done by a master's student I had at TU Eindhoven. So yes, first a little bit of background. So the whole idea was we have these block-based environments, and we think that these block-based environments are better and are good for end users, especially if we think about end users as people that do not have any background in computer science, but really domain experts. When we look at the automotive domain, so there are 2 big systems that we have nowadays, which are advanced driving assistance systems and in-vehicle information systems. So these are 2 of the big systems that are nowadays shipped in those cars. So for instance, an example of an ADAS is, for instance, a lane departure warning system. So when you are driving and then the car notices that, oops, something is getting in a wrong direction, that then you feel like the steering wheel is like trying to put you back in the right track. And then an example of IVs, it's more like vehicle status, navigation, multimedia, and all these type of things. Also communication. So there are many things that are happening nowadays in vehicles. So then somehow this needs to be programmed, okay? So one of the options and the most used is to use rule-based systems. And the idea of using these rule-based systems, it's mostly to incorporate human knowledge using a set of if-then rules. So that's the whole idea. So then someone needs to define those if-else statements so that we can incorporate this human knowledge into the system. So this is how it's traditionally implemented. And then there is also the thing that, well, we need to adapt those interactions, because we cannot just define this like up front and say, okay, this is how it's gonna run forever. But there needs to be some adaptations depending on the environment, right? So when we are driving, there are many things happening in that moment. So somehow the system needs to adapt depending on the conditions. Maybe now it's freezing, or maybe I'm just getting sleepy. So all these conditions are happening when we are driving. So then this is a brief summary where we have a domain expert, and this domain expert needs to define those rules for this system. So I'm not going to talk about all the issues that we identified and also the ones that we describe in the paper, but I want to focus mostly on this one. So we noticed that the syntax might be a little bit intimidating for end users. So I think we are all here programmers, so this might not be intimidating, but if you have never seen this in your life, this will be like, okay, why there are those red things, red letters, words there? What about those quotes everywhere? You also have these square brackets. So if you are not technical person, then it will be like, I don't know what is happening here. This is just magic. So then we also have another problem, and is that the rules grow quickly in number, and the complexity of decision logic also increases. So if we take a very tiny piece of code, then okay, maybe you can make something out of it. But then if you start adding more and more rules, this will just become something that an end user cannot deal with. So they are very powerful, so these type of systems are extremely powerful. You can define many things, but they are in a way technical. So we thought, okay, how can we define a language or describe a language to provide non-technical users with a user-friendly mechanism to specify executable rules for HMI interaction adaptation? So how can we define this language or this additional level of abstraction to specify this type of rules? So this is what we called AHSL. So here we have the domain expert as the entry point where this domain expert needs to define that specification. So that specification, as we define it, is a set of assignment operators where we just assign this value under these conditions. So this is the main approach that we followed. And here we define this small DSL to leverage on top of a tool I developed also called Kogi, in which we take the specification of the language, and from that specification we are capable of generating the block-based editor that you see on the bottom part, but also the textual editor. So all these implementations are made using Rascal. So basically this enables us to take existing languages and then just make a little very tiny modifications, and then we can get a block-based environment for free. And then once we have this already allows us to give the user either a traditional DSL, a textual DSL, where it's gonna be closer to the domain expert, or we can also offer the same language in a way of a block-based environment. And after running this specification, so we compile this to more traditional rule engines where we can run those specifications. So this is a very tiny example of things that we can do. So we conducted a domain analysis to identify the different types of things that are happening in the automotive domain. And on the left-hand side of the screen, we can see the specification of some of those rules. So for instance, we can say that if the traffic risk will be high when there is a vulnerable road user, and by default we say that it's gonna be low, or we can encode something like, okay, the driving demand will be high if the intersection type is a roundabout, okay? Otherwise, it's gonna be low. So we can encode all these different types of situations. So to conclude, what we wanted to achieve with this type of system is that instead of the domain experts learning some particular programming language, Java, C++, or something like that, to define a domain-specific language that allows them to define these rules in a more concise way. Here, we wanted also to, again, take advantage of block-based languages because they are easier for users in different ways. One of the benefits is also that when you have a textual language, well, you don't have this palette of, okay, which language constructs are available in the language. So in the block-based environment, you can just see what's available in the language, and then you can just start playing around with those things. So this is less intimidating for users. This is some ideas of future work that we also presented, so to extend it to other applications. So now we were only focused on this suppressing of messages, onboard messages. Also to evaluate the usability. So again, we now create these block-based environments, but is it really better for end users? We conducted a small prototype and then with non-experts, and it was promising, but is it really good for people in industry really working in the automotive domain? So those are open questions. And also we use only rules as an engine to run those rules. So to explore maybe with other options. I think I went a bit over time, but this is the brief summary of the paper.
Thank you. So let's maybe start with the first part. So what did you hear? What would you say is the summary of this project or the paper? Just in a very objective, neutral sense. What is this about? And maybe if there's online can you check? There's some, maybe Tom also. Robert.
So it's about DSL, domain-specific language, for actually a particular domain. The paper is really clear about the application domain of that DSL, and it claims that by using this DSL, the developers or the people working with the systems could be more concise, and not only by using the language, but also by the tools that support that language.
Thank you.
So what I found interesting from what you showed is the fact that so the end goal is this Broccoli-based environment, but to get there you use a DSL as sort of in between, right? So you come up with the abstractions for this particular domain and express the abstractions in the definition of a DSL, and then you get the programming environment for free from the DSL definition. That's like a two-step process. I immediately have a question related to that, if I may. So I wonder, like, which of the two is like expected to give the main benefit to the end users, right? Is it that hiring the level of abstraction to a DSL, textual DSL, or is it more the visual Blockly aspect?
So that's actually a very good question, and I never thought about it in that way. So our main approach was focused on using the blocks, and we assumed that the blocks, the visual representation was gonna be just like better and easier for the end user. But also, yeah, by analyzing the problem and defining these language constructs in the DSL, well, we are already kind of helping them, because then they can really focus on the domain concepts and not really just in any GPL writing all the code that you have to write, but this is really focused on the domain So I think both have the same goal. I would assume that also because what I mentioned, I mean, if we think about the textual DSL as just something that, well, you have a text editor and then you go, well, then I think the block-based will be better, because in the block-based environment you can see this palette with all the different language constructs. Maybe you can also give different meanings to the colors, so to give really semantics to the different aspects of the language, not just like, well, these are random colors at the moment, but maybe you can also add more meaning to the different aspects that we can see in the block-based one.
So thank you. Well, I also heard things about language transformation or execution, like having a higher level language that's more suitable for the domain and making it somehow work on a lower level execution platform. So let's switch to the second part, maybe merge them. So the I like, I wish part. So what did you like about the presentation, about the idea, how this mechanism works, and what would you wish to see improved? Maybe you have an idea. Whatever you can think of.
So what I liked was the the very thorough examination of the related work, the projects that you looked at, and the way you derived your sort of requirements, the things you would like to address or solve. And what I also liked was just seeing the DSL, the language, and also the tool and its support just really next to each other. And then I was wondering, because usually people talk about their language and tools are often a second thought, if at all, right? I was wondering, just from the end user's point of view, what is more important, the language or the tool support that is based on the language? And then if you always start out with the co-design of the UI and or the tools and the language, how you would proceed out. There is one part or the other that dominates the design. This was a question that came up.
So shall I answer the question right away? Yeah. So That's a good comment, especially like whether it's more important the language or the tool support that we offer for the language. So I think we cannot just say we should focus on making the language and then let's forget about the tools. But I think they really go hand in hand, and I think that's also why my focus here was mostly on, okay, let's assume that we have the DSL, and then coming back to Thomas' question, that's why I never like made this process of thinking like, by just making the textual DSL, well, we are already identifying the different concepts, and then the tools that we use to interact with that language, I think it's essential, and I think there is also one of the limitations of this work is that we, together with the student, we were thinking about, okay, this is what we assume domain experts want to do or want to have. But this might not be true, or it might be true, but then it requires like constant feedback from the end users and the domain experts to, okay, yeah, well, if you are building a car, maybe this is not the setup for building a car. Maybe they're also interacting with, I don't know, X number of tools where they are modeling different aspects of the different components of the car. So how these tools can be integrated into the existing pipeline. And this is also one of the extension points that we want to take for this project, to try to integrate experts in the domain, really building these systems to see and understand how those domains work.
Thank you. Any more comments on what you liked, what you wish to see improved?
So in the paper, there's quite a bit of attention to the assignment concept, and I find that perhaps a bit difficult to square with the also rule-based approach, right? So you want to be declarative, and then there's a notion of state or assignment apparently. And I wonder, is that whether that's something that is inherent to the target language? Or would there be ways of perhaps having a fully declarative specification that still targets the same language?
Yes, so I think that's a very good question, and basically as you described, that was the approach that we followed. So we kind of reverse engineered like how rule-based systems were working, and we tried to say like, okay, we conduct this domain analysis where we can identify the different aspects. So let's try to see how we can match these two together, but really tied together. So I mean, at this moment, well, we are just generating the rules language, the rules language, but we didn't like isolate from there and saying like, okay, let's try to do it in a more generic way that we are not dependent on this one. But here you can clearly see that it has a direct influence on the language. So that's something also that it should be revisited for a next iteration of the current work.
Can we see the Discord for a moment? We have one more comment from Tom. There's Tom. So, yeah, go ahead.
All right, yeah. So in terms of what I wished for, what I liked, I think there's two aspects that I would like to briefly touch upon. One is about the language design, which I think you also discussed in the paper itself. I hope I don't duplicate content right now. We were briefly disconnected remotely.
No, that's fine. But now you're
Okay,
gone.
it's fine. Now it's not fine.
Okay.
Manner.
I think we lost
Can you
for
start? Can you start over, please? We just lost a couple of seconds.
All right, all right. Yeah, it's now stable again, yeah?
Yes.
Okay, excellent. So in terms of the language design, we had these two interesting choices of removing all syntax, which makes it somewhat difficult to be explicit about more complicated Boolean.
I think both pictures froze, so it's
Interesting.
probably our side.
slowly coming back. Yeah, he's back.
All right.
Oh, we
Yeah,
have
here
we
it's
have
quite
time.
nice. Riemann, I can.
Try again.
Okay, excellent. Um, all right. So yeah, in terms of the language design, I mean, it was really interesting. That brings me to my second point, that in the study you actually tested with people that have programming experience, right? And exclusively even. One question that I would have, I'd be curious about if that was an intentional choice to test with people that have programming experience or a limitation. Since that obviously also kind of taints their impression, as you already point out in the paper, right? And in terms of the study design, I was also a bit curious about how long people actually used the block-based editor, since they seem to have very little exposure, since you only had a single subtask and everything else was done in text, right?
Yes. So the first question about if this was intentional, all the users that tested the tool, if it was intentional. So no, it was not intentional, and actually, as we reported in the paper, we made a first run with a non-technical person, and I think the complexity of everything that was around running the tool, like you need to have Rascal there, you need also to generate the blocks. So I think this already added some overhead at the moment of conducting the study. So then that's why we said, okay, this prototype as is now, it's not ready to be used but by a really non-technical person. But it's more not about the application itself, but it was about the whole infrastructure around the application. So that was one of the limitations that we noticed at that moment. So then, yeah, that was the main reason why we decided to, okay, let's see how this goes with people with more technical experience, because yeah, I mean they are more familiar to seeing this type of environments. So I think that's why we decided to continue that path, at least to get some feedback also from experienced developers, maybe not really familiar with this domain, but experienced in the sense of they are not afraid of seeing the Eclipse or the Visual Studio Code window. So that was basically. And what was the second question? I forgot that one.
The question was how much exposure people had to the block-based environment, if it, you think, sufficed to get a good impression.
Yes. So I think the common answer is that sometimes when you show these block-based environments to experienced people, they're like, the feelings are more like, well, they are either meant for children, or if I know how to type it in text, well, maybe I don't want to do it by dragging and dropping blocks. So I found that was a limitation, and one of the users explicitly mentioned this, like, yeah, well, the blocks are nice, but no, to be honest, I just prefer to just type in everything. So I think that's also something that, well, it must be taken into account, especially as an extension, to really understand what are the limitations, but what are also the real opportunities that block-based environments open, and in which domains and what type of languages. So I think it really requires a more extensive study of the usage of these type of languages.
Okay, fair. Thank you.
Okay. Well, I have a question about. Well, you started with showing us some traditional code, and that is really hard to understand, maybe even for programmers. And what do you think about seriousness of the domain? If you want to come into this domain, program an automotive device, and it looks more and more easy, colorful, with the puzzle metaphor, and you want to program the brakes and the acceleration and stuff, and you think about, okay, do we have to also come up with another form of, well, I don't know, teaching? If this is really so simple to program, do we miss something that comes for free with a more traditional, complicated language part that you had to do anyway? Okay, I program some hardware, or you know what I mean?
Yeah. That's a good comment. I cannot talk about the automotive domain, but I can talk a little bit about, because this was also the whole coggy stuff started, because I was working at Canon in the Netherlands, and they were building all these big machines to print like these huge posters. And then I was like, hey, well, I have this nice block-based environment. And then, well, the first time they were like, that looks interesting. But then the second time we're like, yeah, well, but that doesn't look very professional. It looks too colorful. I don't think our engineers would like those kind of visuals or representations. And I think that's one of the main issues that I think this type of more friendly or colorful environments have. But I think something that can be explored is that they don't really need to be that colorful, right? So if the colorfulness of the environment is the problem, you can also try to make it like more professional, depending on what you call professional. But at least for a more industrial setup, I think that's something that really shocks, like, yeah, but this is what my child is playing with. I'm not gonna be doing that. I mean, I went to uni, I have all these years of experience. But I think also, in a way, I mean, when we use Python, I mean, it's way easier than using assembly. And many of us are using Python. So I think it's the same kind of discussion. But I think these type of environments, they have a lot of potential, and also mixed with other notations. So it doesn't have to be just like blocks, text. It can be something in between. We also have node-based editors. Maybe node-based editors can be just like mixed with block-based editors. And then still, you need to have some text, because even if it's a visual representation, well, you still have some text in there. So I think that also comes back to the keynote we had this morning, where, yeah, I mean, the visual programming is also text. So it's more like how we can enhance these abstractions to make it easier to show like, okay, well, with this block, you can do something like that.
Thank you. Let's thank the speaker again. Our next presentation will be a remote presentation supporting construction of domain-specific representations in textual source code. I think Tom will do that.
Yes.
So slides are
can you already
almost
see my
here.
screen?
Yes, we see your screen.
Excellent. If the connection breaks down, you just yell at me, yeah? Then I repeat the last slide.
Yep.
Okay. So, this work was to a large part done also by Jan, a student of ours who collaborated on this project as part of his master thesis. So let me just quickly mute the room here on my end. Okay, no echo, perfect. The area that we are moving in is this idea of domain-specific replacement, which is a term that we use for anything that you want to put inside of your typically general purpose source code to make it more tailored toward a specific domain. I picked a couple of examples here that are sort of like maybe straddling the line of domain specificness. You have one example like interactive visual syntax down here, which is quite explicitly a certain domain, red black trees in this instance. But then a couple of other ones that are sort of like, if you want to call it a domain, you could, but it's more generally a programming tool where the domain itself is maybe programming. So for instance, you have Babylonian programming, which enhances your, in this case, JavaScript source code using examples that you can attach and probes that are then sort of visualizing runtime values as the code executes. Down here, I got a screenshot of Code Bubbles, which is a project that takes a Java project and makes it navigable in a different manner that is better suited towards discovery and exploration. So the common thread in these projects is that they are integrating with general purpose languages that are not necessarily designed for visuals, maybe with the exception of Racket to a certain extent. And if you have this sort of challenge, you have a GPL, a general purpose language, and you want to put something visual inside of it, the first thing that you have to do is somehow attach to it, right? This idea of we have to find abstract syntax tree structures, match against those that interest us, and then extract the data from those in order to construct our user interface that either enhance or replace the part of the source code that interests us. as you can see in these various examples here, replacing certain parts. The goal, this is what this is the challenge that we're tackling, and the sort of goal that we set ourselves here as part of the design was that we wanted users not to rely on prior knowledge of language internals, such as here you can see this expression in JavaScript, const ocean temp equals array of a couple of values, is composed of this abstract syntax tree here, this certain named connections, etc. And these are all intricacies that a user would have to know in order to build this domain-specific replacement. Specifically, we are thus not targeting non-programmers, but rather programmers that are familiar with their program domain, be that red-black trees or data visualization, etc. Now, I talked about matching and extracting. The idea here is rather simple. Our system, whatever that might exactly be, traverses the entire tree and asks your system, the system that we are presenting as part of this paper, given this as node of the syntax tree, is this a node that you want to have? In that case, return something or else return null. And the something that you are returning should be a dictionary, an object of the extracted values that you then use in order to construct the view that is supposed to appear. So these two functions work in tandem. The output of the one gets fed into the input of the other, the one that constructs the view. Okay, so now we have this idea of we find the nodes in our program, we extract values from them, but how exactly are we going about this? The idea here that we came up with is a query-based system that tries to address the sort of complexities in a sort of a direct or less direct manner. So what I mean by this is, for instance, that we offer users the option to specify essentially the same source code that they're already familiar with. So we had this example, I'm just gonna switch back real quick, of this array here that defines a couple of numbers in this variable. And if this is the structure that we want to match, then we can specify it as such that we just say const placeholder equals another placeholder. So in this instance here, there's no intricate knowledge of the AST required. You literally just type the same source code, right? This is not necessarily a novel idea, of course, but this is an important ingredient as part of the system. The other elements then here that you can chain together in this system then work in tandem to narrow down the elements that you're interested in wherever this query system falls short. So for instance, you can extract fields from the object that you're getting. You can run arbitrary code if you need for instance, compare numbers of things. For instance, we have an example where you construct out of a 2D array a table. And for that purpose, you need to ensure that the rows and columns match. So naturally, that is a piece of code that we would be adding here. And then we have a couple of sort of control flow elements that allow you to specify that you want multiple things to be executed in parallel. And if any of those fail, the entire pipeline fails. Or to have multiple things that could happen, and you just want the first branch to pass through, as well as a form of iteration. So for instance, the same example again, this 2D table, if you want to collect each row again, then you would use one of the looping constructs. So this is the first ingredient, more or less visual matching language that also incorporates code, or in that sense, kind of hybrid. And the second one is live feedback and actions. I brought a screenshot here now of a piece of code that looks for typical declarations of colors. You can see here RGB or hashtag value, and those get replaced by color pickers. This is now a view onto the entire tool. You can see here that the pipeline elements that we saw earlier are also in here. And what you have down here in green is the live values for the first example that you specified going through the pipeline. If there's at any point a failure, it would be marked in red, and you would get an immediate feedback form. Okay, given this example, the current pipeline does not match. This aspect is what enables you to still get deep insights into the AST without necessarily having to have prior knowledge into it. So let's look at a slightly simpler example. We have here an array here, an object with RGB channels. And this is sort of the example input that we're giving it, and that is our pipeline here. How do we get to that pipeline? We first specify the simple query in the same system that I showed you earlier that literally just says, I want an object that has color channels. We can then open this feedback item here. This is an object explorer of the very thing that we just captured, and say, okay, of that object, I want to extract the color channels field. That gives us this extract step here in the color channels. We then need to ensure that all of the values are numbers for this purpose. And we can say simply, okay, the system recognizes this to be an array since it has the runtime data and offers contextually valid actions, which means anything that deals with iteration since we're an array, allowing us to either say we need to ensure something for everything or just we want to run over everything. In this case, we want to match over everything. And thus get this match all suggested here and created. Subsequently, we access the field value of it. Again, we can sort of use this object explorer to drill down, right-click the field that we're interested in, and the system contextually derives what sort of actions are sensible at this point. And in that way, we can just kind of narrow things down until we have this assertion that we want a number type in every single field of the color channels object over here. Exactly. So a couple other things that happened in the paper is that we offer users AST over editing primitives. So when you are inside of your view code, that you can transform source code in a way that remains syntactically valid without having to pay attention to every single comma or white space. We offer a couple of built-in UI components for text editing, editable code. We have some evaluations, the color picker that you see here, the 2D array that I mentioned, and the tool itself. I'll briefly show you in the tool. This also highlights one of the major limitations. It gets kind of big. So yes, this is definitely not something that you can easily build in the tool itself, which is why we formulated this first and foremost textually and then loaded it into our system. And finally, what we derived as conclusions is that it generally works for the purpose that we specified. However, there are obvious scalability issues. There's still some expertise needed for editing steps, and there's often some mismatches between parse structures as parsers typically give us and the kind of structures that users might mean to match. So for example, you might mean to say, I want a member access, but there might be 3 different ways to say member access in your language, and that creates obvious friction here. All right.
All right, so let's thank the speaker. So we start again with the, what did you see? What did you hear about? I saw a color picker. What did you see? Who wants to go first? Or is it? There's the mic.
Well, first, thank you, Tom, for the presentation. So I understood that in the paper that, for instance, building these domain-specific representations in textual source code is hard. And this is a way of how to leverage that and how to implement these domain-specific representations without having to really know all the underlying host language that you are using to develop this. So that was one of the key messages.
There's a nodding. So
that's good.
Sounds about right. Yeah. So more summary behind you.
So we're doing this. We're phasing the feedback.
You can also ask a question if you want. You can answer it.
So I should just do the summary part.
Criticism comes later.
Yeah.
Yeah.
Should always. Okay. What I am I supposed to summarize this and I can't say what I like about it, or can I say what I like about it?
Not yet, but you can keep the mic, and I will switch to the next round.
All right.
Okay, one more. What did you see? What's we see another block-based editor. Maybe what's different comparing with the last talk?
Yeah, so I observed an attempt to try to generalize, to abstract the sorts of operations or development patterns that we see in textual DSLs.
Okay, then let's switch to the second phase. What did you like? What did you wish to see improved? Maybe you have an idea?
Okay. What I really liked was the insight is that ASTs suck. They're really a pain to work with, and there's this sort of dominant ideology that they're theoretically correct and therefore it's the right solution. But I think you've got a really good case here where it's really not that great a solution. They're really complicated and hard to work with, and so I really I love that you're trying sort of to sidestep the complexity here.
Can I say something?
Yeah, you can.
So
go ahead.
What I like about it is that it kind of proposes this end user meta programming idea. So programmers aren't really meta programmers per se, but when do they become one? Well, when they have goals that have to do with meta programming. And then the teaching element or making that simpler, that really I think is not new, but a very appealing idea. And the paper is an enjoyable read, and it presents some ways to take strides towards that. But I do think that there is still a lot of work to really make this fly very far. And of course, lots of people have lots of different backgrounds in different programming languages, and some of the steps just kind of look familiar in different ways, I suppose. And what kind of abstractions one would choose is kind of dependent on what your background and knowledge is. But I found it interesting to see this particular approach. So I enjoyed reading the paper. Thank you.
So we already saw some kind of cluttering in the live demo Tom quickly showed. So what else do you think should be improved in the future? Is it just about visual representations, or is there some cognitive aspects to it?
So what I liked is that the tool very much tries to help the programmer by making these kind of suggestions. What I would like to understand better is in what ways the programmer can still make mistakes, right? Or specifically kind of semantic errors, and in what ways the tool might be able to help, first of all, present the error, and maybe also to help address the issue.
Tom, do you want to comment?
Yeah, thank you. So there's multiple aspects, of course, that could introduce mistakes. One of those I already mentioned, whenever the AST introduces ambiguity, where your intent is to match a large group of patterns that to your mind are the same, but in the AST happen to be different. And for this purpose, the only real solution the tool offers is for you to collect sufficient examples such that the tool can give you the feedback, okay, for these instances it works, but for that one it doesn't, right? Beyond this, if you do a simple programming mistake, such as in this case, you put the wrong regex, the live tooling, the live feedback here will actually give you in an immediate sense that here you made a mistake, and then you just have to drill down in the typical manner to understand what is happening. The nice part is, of course, that you can inspect the objects that the pipeline, that pass through the pipeline here and understand what the structure is of them, akin to a debugger without having to invoke it in the first place.
Any more comments or ideas on this project? Sure. So we are now in this anything goes last minutes. Yeah.
So I mean, I should also add that I think the paper is really well written and very easy to understand, and I always like to thank an author for doing that. One thing though, you did a sort of like a little survey of grammar query languages, and I think your key idea is to try and use the concrete language syntax, right, as the parsing, as the matching thing. I seem to recall some work in Rascal doing that also. I can't offhand remember what that was. But anyway, so my main question here is your visual syntax with the boxes and the lines and so forth, and I think you even mentioned during this presentation that there's a textual syntax that you can use behind this, right? So, a big question here is going to be, well, why not just use that textual syntax instead of these boxes? Is there any real difference in the experience between one and the other? And it's also just nice, that's kind of a controversial thing. It would be nice if you sort of separated that out as a independent dimension here, that you could still use the textual form of this to do all of this, and some people who may not like visual programming won't be turned off. Okay, and the other thing is, since AST theory is so well developed, right? A question here is just, what is the expressive power, right, compared to that stuff of this language? Is there an easy way to tell us, well, this is easier for easy cases, but there's some hard cases you just can't handle, or can it handle everything? And then that's another thing I'd like to know.
Yeah, very good points. So on the first question, why not just use text? Jan and I both extensively use text because the tool is bootstrapped in the sense that it uses itself to match things, right? And the experience is night and day, at least for us. Here you get the live feedback. You immediately realize when things don't work. Whereas when you use text, you have this big black box that is also kind of hard to understand because you have this data flow notion where it's kind of difficult to put breakpoints in a manner that you can quickly walk through it. So this is, I think, one of the classical examples where the sort of snapshot that a debugger gives you is just not as helpful, but you need a domain-specific debugger that gives you a sense of the entire progression of the data flow. So I think the lines would not necessarily be a requirement here, but you definitely want to deeply intertwine the feedback mechanism with whatever notation you use in the end, right? So we could very well imagine everything here being text, but this feedback mechanism to still appear on the right-hand side. I think this is the essential part to take away from this work. Concerning the second question, the expressive power, the main product that we based this sort of syntax on is called AST grep, which is focused on these patterns of ASTs here. And they also have a YAML-based syntax because you very quickly run into cases where you want to specify something as like a regex to go deeper into the system. I would like to claim that there's no ceiling to the complexity here because in the end you can just write code and that allows you to match any sort of structure. And for all the tools that we have tried, there have been helpful abstractions in here to kind of tame the complexity that comes with just writing code. So I think there is definite promise here, but we still need to make a better effort to exactly specify what aspects of this notation of the query pipeline are the deciding factors for making it easier to work with these complex AST structures.
Mauricio?
Yes, so I was wondering more like as a part of the future work, and I think this is also related to what Jonathan mentioned. So for instance, have you also considered, or are you considering maybe the cognitive load that having this mixed or this hybrid type of editors might have on users?
I have not yet. That is an interesting point. I think the main part that we want to investigate first and foremost is to get rid of these excessive menus. They are an obvious quick way to make these interactions happen, but it makes it very sluggish. One of the reviewers also, I think, wrote that it does not bode well to see all the menus, and I would agree. They're just a very easy way for us to make these interactions possible. So I think a mode that allows you to use both keyboard, or rather to use the keyboard inside of these visual structures, hopefully gets users in this sort of form-filling mindset, which I think people are quite used to from other applications, and thus would not have the sort of dissonance between their mouse and their keyboard that would probably contribute to cognitive load.
Is this something that could benefit from Yoshiki's Greenlight platform? Like having a shared space, thinking about these expressions, working together?
I mean, I would say always and in general. I think this in particular would benefit from the fact that you could probably source a lot more examples if you had more people just typing code into it, formulating the query itself. Certainly if you are in a close communication loop as well.
Any more comments from the audience? One more comment?
So this is perhaps a suggestion related to the last point also about expressivity, is that I think it would be nice to have that this set of patterns that you've captured with these kind of interactions that you provide is open-ended, and that perhaps it would be possible for users to, when they identify their own patterns, or that they identify that they're writing code in a certain way repeatedly, that it would be possible for them to add their own elements to your environment. Is that something that was already considered, perhaps? And of course, then the implementation needs to be extensible in a certain way.
Yeah. One of the major points where we noticed this was actually with Smalltalk. Not sure how familiar you are with the language, but there's typical ways to construct objects. These are three of the very typical means to specify that I want to construct an object. And these are actually completely distinct AST structures. One is a unary message sent. This would be a keyword message sent as the root, and this would be a cascade at the root. But the intent is always the same. So this is one of the things that we instantly, once we encountered this pattern, introduced as users of the system, if you will. But we currently don't have a good way to allow users to visually integrate their own extensions in the sort of visual grammar that we have. So that is certainly something that I haven't thought about yet. Yeah.
Jonathan?
Yeah, I just wanted to I guess, amplify Remer's comment that I think this is really cool. I mean, it is kind of trying to make metaprogramming for the masses, language metaprogramming for the masses, and I just really like your attitude of trying to cut through the complexity of the abstractions and make it simple. So great, keep it up. More like to see you continue this.
Let's thank the speaker again.
Thank you all.
And now comes the final talk of the session, bridging incremental programming and complex software development environments.
Okay, cool. Oh, can't see that. You see that? Okay, awesome. I'll begin then. Hello everyone, my name is Max Baksum. I am a student at University Amsterdam. I'm currently doing my master's program. I'm pretty close to finishing. But yeah, I'm going to give a talk today again for my paper, Bridging Incremental Programming in Complex Software Development Environments. So the kind of the motivation behind this was that I feel there's two kind of key software environments that most developers are kind of utilizing nowadays. The kind of traditional one is the text-based IDE environment, so whether that be VS Code or even stuff like Vim. Everything's very structure-based, everything's located in files, and as well the code in general is kind of scoped in aspect like this. But then you also have kind of, because this is the norm, and by far most software companies are utilizing this, you have also a lot of community, if it shows, community kind of extensions that can kind of be built upon this to kind of, get more understanding of the complexity of the actual software system themselves. So the other side of this that's really coming into gear now is kind of the incremental programming environments, like which I will say. And that kind of involves REPL-based environments, and as well, kind of going on top of that, computational notebooks, like you see in Jupyter Notebook. What's really key about this is kind of the incremental approach from this, so it's very iterative, and you're able to really kind of explore and experiment with different types of code fragments as you're going through the development process. So what I was kind of thinking was, how can we bridge these two environments to kind of abstract this incremental aspect and kind of exploration, and as well as really trying to grasp the complexity of big software programming environments. So the idea we had in our head was kind of put this in a graph structure. So basically, instead of cells you have in a Jupyter Notebook or REPL, you have kind of independent nodes that are in charge of their own programming. And then you kind of have the structure as well embedded in it based on relationships. And you can maybe even classify different nodes as potentially meaning separate things, for instance, class nodes or code fragments or method nodes, and they all can kind of have a big picture of what things should be representing. So yeah, that brings me to kind of the prototype that we developed. It's called the Incremental Graph Code, IGC. It's a bit small, but yeah, it's really kind of an environment built upon these fundamentals that we just mentioned. So yeah, I'll talk more briefly about it. I don't want to go too into the details about like the technologies that we made, but currently we just did it as a test case. It's supporting Python, and it's very, the idea is to make this very extensible and to have kind of a community build features and different nodes and different relationships behind everything. This is a little bit cluttered, but kind of it gives you a picture of all the things you can kind of represent, whether that be dependencies or executions or documentation nodes in general. So kind of the idea when developing this was to have a couple of case studies that we want to perform. So completely on the incremental programming side is how can we kind of represent a computational notebook directly in this environment itself. And this is also kind of idea as completely on the opposite side. So the kind of the IDE understanding or the environment on could we really encapsulate that? But these were the 4 case studies. It's a computational notebook which we prioritize in the paper that we'll show a little demo of. We'll also try to do like a protection. I think I spelled this wrong, but yeah, it was kind of inspired by Pascal J from the previous year's session. And then there's also kind of a compositional or architecture view that you can kind of rearrange the nodes in a way that almost resemble maybe some UML diagrams or class diagrams or something like this. And then as well, further going on that is kind of the exploratory view where you can mix and match different kind of executions and kind of compare different nodes. So that brings me to kind of the demo. I have a video demo that I'll kind of talk over. If this is playing, I don't think we have audio. I'll play here. So this is kind of initializing the environment itself. I just call it test IGC. So when you create this, a IGC file, then you have kind of this blank workspace. So right here, I create a node, and right here is kind of like the list of nodes I currently have, but we're just going to test with the code fragments. I can rename it kind of here, and then I just do a quick refresh to be able to, let's do like a quick test for code to actually embed that in the node itself. So I do a quick, this is a test Python script. But then let's also make a documentation node or some markup that kind of is associated with this node. So this takes any markdown text, and then when you actually click on the node itself, it shows above the code snippet. So now I built like a little bit more of a complex system already. That was actually shown in the showcase I have in the paper. So everything is kind of already pre-built in. But if I want to execute anything, nothing will happen until I make a session. So all the executions are kind of gathered all in what's called, well, I call it a session. It initializes as kind of like an empty set, so nothing happened. But when now I try to execute the code itself, you have this little relationship arrow that comes out from this very, how we call it, start node. And then you kind of can see all the output and the errors and the configuration, or like the data that comes out of it. Because there's no print or anything, there's no errors, nothing's really going to show in the output. But you can continue kind of branching off from this initial node to create like any kind of program that you potentially want to create. And it kind of compounds as you're building this, this program, and as you can see on the very left side. So this is everything executed all in once. I also created another session, but that's kind of behind the scenes. But you can see kind of the output at the very end is encapsulated from all the previous nodes that, that executed itself. Yeah, so maybe there's a use case where I want to try inputting different input data. So I execute kind of this sub-branch based off of the initial. And then I can kind of see the data that kind of changes between this new input data that's kind of all feeded back through this system. This was not shown too much in the paper, but this is kind of a projectional view that shows basically an entire Jupyter notebook based on the actual execution projection that's here. And you can also just categorize it directly by documentation. So if you only want to see documentation, you can do that. And then you can also just show the code itself. And then finally, you also get kind of the configuration at the very end on that. I also show, I believe, kind of another view that dictates kind of the two different branches that are embedded in the system itself. So you have the input data 1, input data 2, and then you kind of have the raw data that's encapsulating the entire environment itself. So that's the demo I want to show you. Oh, it's reloading, it looks like. Yeah, I'm not going to go too deep into the program because I'm already way over time, but that's there. And then some kind of related work that a lot of this was kind of inspired by or has a lot of similarities to. So that's it. Thank you very much for listening.
Thank you. So let's start again with the boring part. Summarizing. What did you hear? What did you see? But it helps sometimes to rephrase it so so that the speaker can see, okay, what did you actually hear? So I saw an IDE and with some visual programming, then some traditional programming connecting several views, and it looked more like an Visual Studio IDE than like a Smalltalk environment, probably because of the window management, but I don't know. So just some. Okay, Mauricio.
Yeah, so I think also based on the last examples that you showed us, I think the paper it's really interesting because it allows you to build different types of incremental programming environments, as you call them. And I think, for instance, the notebook view that you showed and having the possibility to just see the documentation. Sometimes you just want to see the documentation. I think this is a very interesting approach to build these custom notebooks or behaviors and not just the rigid Jupyter notebook structure.
Yeah. This projectional view was very based off of this Pesquet paper that was introduced last year.
Yeah, now we can also see the Discord. Two Discord faces. Tom, what did you see?
Yes, I think it's really interesting that, or rather to summarize what I heard, the authors put the sort of tension between a full programming environment and an incremental programming environment, and then try to reconcile the design through this idea of the graph structure, which makes the execution flow explicit in this session concept. I think those are the main takeaways for me.
Thank you. Then let's switch to the second part. So what did you like about the project? What did you wish to see improved? What other comments do you have?
So I did like the way the authors looked at the tools we use to program and also to support different kinds of activities, like ranging from exploratory programming supported by REPLs or notebooks to more traditional software projects toward just regular applications. And also based on that, just looking at the properties we would like on both ends of the spectrum, and trying to figure some requirements to just combine them in a joint tool chain maybe. And in particular, from the technical point of view, I like the idea of making sessions explicit of first class, and with that helping people from the notebooks community to make their computations reproducible, repeatable, and also comparable. So I think the sessions stuck out for me as one of the main contributions.
Yeah, I also really like the sessions approach, this like generating the execution traces. And as somebody from a Lisp background, I wonder, like, yeah, if you should also maybe talk about kind of some of the limitations that some of the, like the Python REPL has, right, where you can't do everything, but there is environments where you can. And yeah, maybe some suggestions for other related work. So I also work on a computational notebook with incremental computation for Clojure. It's called Clerk. And there's maybe Streamlit for Python that's also similar, and Pluto for Julia.
Tom, can you hear us?
Were you talking to us? Sorry. Okay. Yes. So the 2 points that stuck out to me, as I mentioned already earlier, the execution order, and I think it was especially interesting in your related work. You talked about
Sorry, we can hear you.
saying that solving this generally, this idea of modeling these dependencies and the update change that then arise is too difficult, and thus you modeled it explicitly using the order that people execute the cells in, right? So I think this tension between trying to support something general and thus not doing it in a sort of principled manner, but asking the user to derive things is rather interesting here. But I'm still a bit
Frozen again.
Can you repeat the last two sentences?
Can you
repeat the last? Okay. The sessions concept is not 100% clear to me yet. How exactly it interplays, like when you change sessions, if I can clean up sessions, how I share them. But I think those are maybe also questions that are in your future work.
Rimmer, did you want to say something?
I like this approach. Very well presented, Max. I also like this paper. The idea of what you're showing here is, in my mind, ringing like a debugging view on notebooks, and so they could like relate to omniscient debuggers, or maybe like a generic.
You're frozen again.
Ring as something negative, because there are certain approaches that didn't work, including from the Godot engine that I like very much. Like there is a visual language in there, an old one they removed. I use their visual frameworks now to make DSLs. But not everybody enjoys these types of representations. But if they are optional and offer the users a particular way of interacting, then I suppose that might work. But yeah, I'm actually curious to see how it will be applied more in practice. That was my comment. Thanks.
Yeah, no, I mean, that's also, it's very hard to have people transition to a new environment when they're very familiar with their own original. So the idea is to kind of have this approach where users from potentially are very familiar with computational netbooks or very familiar with IDEs to try to have features and try to have this new hybrid environment suitable to, if you only really want to do these computational notebooks, you have a way to do this. If you only really want to focus on kind of more this IDE approach, you could potentially just create a node and have all your file structure or all your content exist in this node, and they can interact still with different files and imports. So yeah, there's a big kind of consideration on this point. Another something in the future work is actually to be able to export back and forth potentially between these different environments, and as well the other way to go into this new environment to kind of bridge this transition, hopefully.
Thank you for the presentation. I think like whenever we find issues in the programming, issues in just the programming ecosystem, I feel like a lot of PL researchers tend to focus on the language and the semantics and the syntax and like ways to improve the language itself. But I think like we often neglect, I guess, the tooling and the ecosystem and the editor around it. And so like any research that advances and experiments with like new ways to edit, I think is extremely exciting to see. Something that I always have in mind when I see these kind of things is that whether like the technology for incremental compilation and those technologies have like advanced enough that we can actually just embed this, because I feel like the idea is extremely cool, but as like if I imagine like really big projects with a lot of dependencies and with a lot of imports and a lot of code, I think like it might take a while for like all the graphs to update and like all the code to compile, and so like it might not be as smooth of an experience trying to like expect like a REPL like incremental development.
At a point, yeah. No, I mean, like scalability is like a very big issue, and this point was definitely kind of thought across. The idea to maybe kind of combat where you have a graph full of hundreds of nodes is to have kind of a composition node. So potentially have sub functionality. This can exist all in a separate file, where this file can then be embedded in just a node itself. And so you just execute this one node, and then you kind of continue on as you normally do. So your main, I guess, your main file per se, or your main graph, would then be a lot simpler in this respect, because all the complexity is kind of put into other files. You still have this issue, of course, with the actual execution, because you always have to kind of go through all these nodes. But yeah, this is something that has to be addressed with scalability and kind of performance aspects.
Any more comments or ideas about the work?
Yeah, so maybe you can explain something about how the session management actually works. So how you have this you have a kind of incremental execution, right?
Yeah. Yeah. So session management basically, I went over it very fast, so it makes sense. It's a little confusing, but basically a session kind of represents maybe a run space. So everything is initialized at this kind of start node. So when you create a new environment or a new graph, you're only left with a start node, and this is representing basically an empty set. Nothing has happened. But then when you start creating these new nodes, you then can execute only if you're inside the session itself. So you can kind of compare and contrast between different sessions or different executions. So maybe you're interested in kind of running this subset, but maybe you want to do a quick test. So you make a new node, and then you can kind of write a sub code fragment, and you want to kind of experiment on that side. You could then kind of copy that state all over to another session, execute this one node, and see kind of the outcome behind everything. So I don't know if that clarifies a little bit, but yeah, the idea is, yeah.
We have 3 more comments, Tom, Robert, and then you.
Yeah.
Tom?
Yeah, just quickly echo something that Rima and someone from the audience said as well. This idea of having classes and methods on the canvas struck me as a bit surprising, because in particular, it doesn't really make sense in my head, at least, what it means to execute a method node on the canvas. So I'm wondering why it even has to be on there, right? And in the reply that you gave earlier, you also mentioned that you could just include an entire file as a node. This also strikes me as a bit of a dissonance in the way that the canvas might want to be used to show the overview of the project, but now it's hiding a lot of information. So maybe the design would benefit from decoupling those two aspects, execution and sort of the project that backs the execution. But I would also be very excited to be proven wrong and to see that there's actual merit in putting all of this information on the canvas in a way.
Yeah, to go over your first point, the idea behind kind of having these classes and methods was really just the structural aspect. So really to kind of devolve this complexity that you have in the big software systems. Of course, not every language supports object-oriented programming, but that's kind of the aspect that I kind of wanted to show here, because it's also beneficial, I find, to have these different types of node types and different relationships, and how could we kind of represent it in this sphere. But yeah, in terms of execution though, in the kind of sub-picture I have, what you would normally do is you would first execute kind of the class definition, and then execute kind of the methods that are embedded after that. There's of course probably some way that we could probably automate, hey, let's execute this entire class. Maybe you put this in maybe a separate file or whatnot. But yeah, maybe there is maybe also a use case where you don't want to execute every single method that exists from a class or so. But it gives you kind of this flexibility to be able to do this, I guess, in the current implementation. Going to the next point that you made, yeah, I agree. Putting all this code kind of in just one node and executing that and putting it somewhere else is kind of defeats the purpose of this complexity aspect that we're trying to solve. There is a feature kind of in the works that is going to analyze the code and maybe try to expand this and into kind of these node types that exist here. So maybe every single code fragment, every expression kind of is split up between code fragments, so you can kind of see this all there. But yeah, it's really, in summary, it's really up to the developers, I guess, will to do or how to formulate this however they want, right? They can make it very simple in terms of the actual development time, or they can make it a little bit more complex where it's really readable and it kind of can withstand a lot more of the complexity aspect.
when reading the paper, it sounded like you wanted to improve not just notebooks, but also wrappers and traditional IDEs. And then also in the paper you wrote that for now you focus on notebooks for whatever reason, and then next steps would be to address all the other areas, like two of them. And first I was curious how things might work out, and looking forward to the next presentations in those other two areas. But then I was wondering if it looks like you pretty much focus on notebooks, and then why not just sticking to that and just focusing on actually the notebooks and improving just them, and not just trying to cover the entire spectrum?
Yeah, it is a very ambitious goal, I guess, to do this. The real motivation to try to cover everything is because IDEs and text environments are kind of seen the norm in kind of traditional software engineering jobs. But the idea is to how can we kind of get a lot of kind of the features and the advantages that you see in REPLs or computational books with this incremental programming, and how can we kind of allow developers in this field that's maybe not as exposed to these REPL or incremental programming environments is what I call. How can we kind of have them or allow them to feel comfortable in their own kind of IDE text environment, and then be able to utilize a lot of these kind of features that you have. So that's kind of the understanding. It is, yeah, very ambitious to kind of cover these two aspects, because there are tons of kind of things you can do in all these independent environments. But yeah, that was kind of the thought behind it. Yeah.
Hi, nice talk. So what you've really built here is some kind of program meta database, and I'd be really interested in seeing future work that squeezes the juice out of having this information available. Like, based on this remark about concerns about performance as the program scales up, if you have all this information about your program available, it would be very cool if behind the scenes you have all sorts of tricks. So I could imagine you already had an example of these two sessions that have a common prefix, right? You can imagine that, with some fancy analysis, it could recognize, okay, I'm going to be doing lots of computation. Again, I could do some kind of checkpoint, and then, for some programs this would be acceptable. And then when I run the second session, it's actually just continuing from this checkpoint. And you can't do this if you don't know that they have this common prefix. You've already put in the work to, capture this useful property.
Yeah, correct. Actually, behind the scenes, what's happening is that it's actually capturing the states from every node, and it's saving this into kind of a file. So you're able to, in this path, in your example as well, once you have this prefix, you don't really have to recomputate everything that was coming from behind. But the problem with this is that you do have maybe issues where potentially you have a node that comes from before that changes in some way, or is affected. So currently, kind of the live aspect of this is not implemented. You have to kind of execute the entire execution path for this. But no, that's something that's already kind of embedded in the system, and is kind of planned for the future to really harden. So.
Let's thank the speaker again. And now I think we're doing some hybrid conclusion. Tom is still there. Mauricio is here. Mauricio has a microphone, so maybe he starts, and then Tom will chime in.
Okay, so with this last presentation, we conclude the program we had for Paint. So thank you so much all for being here. Thank you authors also for submitting the work. I think we had like a very nice setup where we managed to interact a lot at the different levels. So I'm very happy for that. So thank you so much again. And we hope that we get also more submissions next year, and then we can keep like Paint alive. So Tom, I don't know if you want to say something additional.
I think it is appropriate for me to also thank the audio team specifically. I think it went really well in the end after some initial hurdles. So excellent that you made this work on such a short notice. Thank you.
Okay, so perfect. Thank you so much. And Yeah. We're also more than happy to receive feedback later during lunch. Robert is here, I'm here, so feel free to reach out. Okay? Thank you so much and enjoy the rest of the conference.